Welcome to Homework Lib.
This problem has us looking at conduction and valence bands in diamonds. So we're told by the problem that the gap between the valence and conduction band in diamond is 5.47 electron volts. And that is the gap between these two bands. And the question wants us to find A, what's the maximum wavelength of a photon that will excite one of these electrons up here into the conduction band. B, explain why diamond is transparent and colorless. And C, explain why most gem diamonds have a yellow color and how this color can come about. So we'll start out with our wavelength uh, deduction here. And what we're going to do is harken back to the often used energy of a photon, which is the Planck's constant times the speed of light all over the wavelength. So in this case, if we want to move an electron from the valence band to the conduction band, it's going to take 5.47 electron volts of energy. Thus, our wavelength will be given to us if we take hc divided by that 5.7 electron volts. And I have worked it out already. And we get that the wavelength of the light is 227 nanometers. And the question also asks what region of the electromagnetic spectrum this photon lies in. And that is just about in the UV range because it's slightly less than the visible light range of about 300 to 700 nanometers. So then on to part B, we want to explain why pure diamond is transparent and colorless. Well, anything that is below this wavelength, so any wavelength that is higher in energy but lower in wavelength because the way that they are related here, it's going to excite and thus absorb those wavelengths. So any any wavelength lower in energy or above this wavelength is going to pass right through the diamond and not excite any of these valence electrons. So that's to say that wavelengths above, we're going to say excitation wavelength, passes through for the reasons I said just a little bit ago. And if they pass through, then you can see them, and thus they have uh, some effect in your eyes when they make it to them. And then for part C, it wants to explain why most gem diamonds have a yellowish color and how impurities in the diamond can cause this color. The most One of the most likely solutions here is not coming from the valence structure of the diamond itself, but from the impurities within it. So if we have a block of diamond here, and if we have some imaginary impurities that, maybe they look like this. If you have light coming in from the outside, let's say it's coming in here, it refracts a little, hits this and it's scattered a little bit, which changes its wavelength, so it turns to a maybe a lower energy, which in this case I'm going to represent by green, but it would actually be something like more red. But it's this process that you can think about as a way that you can change your color even if the electrons are not absorbing the energy of the photon. So it could be from collisions with these impurities.